Assalamu alaikum warahmatullah. Today we will be solving some selected questions from January 2024, Unit 2. So, firstly, we move on to section A. Question number 1, which says, which compound has intermolecular hydrogen bonding? Now, in order to have intermolecular hydrogen bonds, only 3 bonds or only molecules that have any of the 3 bonds can form hydrogen bonds. One of the bond is HF, the other bond is NH, and another bond is OH. So if you have 3 bonds, these 3 bonds, HF, any molecule that is HF, or any molecule that has OH, or any molecule that has NH, any molecule containing any of these bonds will be able to form hydrogen bonds, right? So option B, C and D don't have any one of these bonds, and that is why B, C, D is not the answer. A is the correct answer. Move to question number 2. It says in which process are intermolecular hydrogen bonds broken? Hydrogen bonds are involved. See, I told you before, hydrogen bonds are involved only in molecules that have OH, HF, or NH, right? So the options A, C, and D don't have molecules that have any of these bonds. Only B has OH bonds in it. So B will definitely be the answer, because when you heat water, it turns into H2O gas. So the hydrogen bonds between the water molecules are broken down, and that is why they turn into gaseous molecules, right? Question number 3, it says molecules, a compound that has molecules with non-polar bonds and permanent dipole forces between its molecules. Now if you look here, if you look at nitrogen and oxygen, so I have already placed the Pauling electronegativity index, which is found in the data booklet, because they asked you to use the data booklet. So this is the part of the data booklet which shows the Pauling electronegativities. So if you look at nitrogen and oxygen, so now if you look at nitrogen and oxygen, they have a difference in electronegativity. Nitrogen is 3.0, oxygen is 3.5. So there is a difference in electronegativity, and that is why nitrogen has polar bonds. So the first criteria is not met. So nitrogen monoxide cannot be the answer. Then we have beryllium chloride. You have beryllium and you have chlorine. Now they have different electronegativities. So they have polar bonds. So that's also wrong. Now if you look at Ci4, carbon and iodine, carbon has an electronegativity of 2.5 and iodine also has an electronegativity of 2.5. So these are molecules with non-polar bonds. So these are molecules with non-polar bonds. But Ci4, this molecule is tetrahedral. Now this molecule is tetrahedral. Now since this molecule is tetrahedral, the dipole moments will always get cancelled in a tetrahedral molecule, and therefore they cannot have permanent dipole forces. So Ci4 can't be the answer. Now in case of pH4, if you look at phosphorus, where's phosphorus? If you look at pH4, phosphorus is 2.1 and hydrogen is also 2.1. So then they don't have a difference in electronegativity. So these are molecules with non-polar bonds. So the first criteria is met. The second criteria says it has permanent dipole forces between its molecules, because if you look at the shape of pH3 is trigonal pyramidal. If you draw the shape of the pH3 molecule, the pH3 molecule is trigonal pyramidal. Right. Now, if you draw the shape of the pH3 molecule, you would see that there is a lone pair. Now, these bonds are non-polar, right? They don't have dipole moment, but the lone pair has a dipole moment. A lone pair always has a dipole moment, and that is why this molecule will have permanent dipole forces between them because of the lone pair, and that is why C is the answer. It's a very different question. Usually you don't get such questions in the exam, but this is a rare question. You might get in your exam too. Then we move to question number 7. It says which reaction involves the oxidation of a group 7 element? Now If you look at option A, in option A, the fluorine is reduced to fluoride. The oxidation number is -1. So the oxidation number of fluorine changes from 0 to -1. So here the halogen is reduced. But the oxidation number of bromine increases from 0 to +1 because the oxidation number of bromine here is +1. So therefore definitely reaction number A involves the oxidation of a group 7 element. Now if you look at other compounds, the halogen is getting reduced or either they are getting reduced in the other options, either the halogen atoms are getting reduced or they are or there is no change in their oxidation number. For example, here the chloride ion has an oxidation number of -1 in on both sides. So there is no change in oxidation number. So if you look at option C, the oxidation number of fluorine here is 0 and the oxidation number of fluorine here is -1. So the halogen is reduced, right? Okay. Now we move on to the next question. Question number 8. It says equal volumes of 0.01 moles per Dimples solutions were mixed. Which pair of solutions gave the greatest mass of the precipitate? The greatest mass of precipitate will be formed in B because B will produce two different precipitates. Because when you react, when you react A, it will give you precipitate of AgCl only. If you react C doesn't give you any precipitate. If you react D, the substances in D, they will give you a precipitate of barium sulfate, right? But if you react the substances involved in option B, barium chloride and silver sulfate, so it will form the greatest mass of precipitate because it will form two precipitates. One is barium sulfate. One of the precipitate will be barium sulfate. Another precipitate will be silver chloride. So this reaction will produce two precipitates. So therefore this will form, B will form the greatest mass of the precipitate because it will form two precipitates, because barium and sulfate will form barium sulfate, which is a white precipitate. Silver and chloride will form AgCl, which is also white precipitate. So that would give you the greatest mass of the precipitate, right? Then we move on to question number 11. It says, what is the mass of nitrogen atoms in 50 cm cube of 2.0 mole per Dimples solution of ammonium nitrate? You have to find the mass of nitrogen atoms. So initially what you do is you find the moles. Of atoms. Oh, not atoms really. Initially what you do is you find the moles of ammonium nitrate. The moles of ammonium nitrate will be 2 into 50 into 10 to the power -3. Concentration multiplied by volume. If you multiply concentration and volume, you will get the moles of the ammonium nitrate, right? Then you find the moles of nitrogen atoms. Now one ammonium nitrate contains two nitrogen atoms in it, right? So the moles of nitrogen atoms will be 2 into 50 into 10 to the power -3. The moles of nitrogen atoms will be twice the moles of ammonium nitrate because one ammonium nitrate contains two nitrogen atoms in it, right? So then you find the mass of nitrogen atoms. Therefore mass of nitrogen atoms will be equals to 2 into 50 into 10 to the power -3. You multiply the mole by the molar mass. So the molar mass of nitrogen is 14. So if you multiply by 14, this comes out to be 2.8 grams. So therefore C is the answer. And if you have questions, you can always write in the comment section. Then we move on to question number 13, which says, which statement best explains why the rate of a chemical reaction increases with increase in temperature? Now, if you increase the temperature, activation energy will never decrease. Activation energy would decrease if you add a catalyst, right? The rate of a chemical reaction increases with increase in temperature because the number of collisions increases. Yeah, that is a correct statement. The kinetic energy of the particles increases. That is also a correct statement. So B is a correct statement. C is a correct statement. D is also a correct statement. right? Now it says best explains best. See, in the class we studied that there are two reasons why the rate of a reaction increases. Whenever there is an increase in temperature, if you increase the temperature, there are two reasons. When you increase the temperature, there are two reasons why the rate of reaction increases. There are two reasons. One of the reason is that the frequency of collisions increases. Frequency of the collisions increases. That is, they are talking about the number of collisions per unit time. And also the energy of the collision increases. Both increases, right? Frequency increases, also energy increases, right? So it says the best explains. Now option D is basically like a combination of both B and C. The frequency of collisions. They're talking about frequency of collisions. Frequency of collisions with energy greater than or equal to activation energy increases. Collisions or particles that have energy, particles that have energy greater than or equal to activation energy, these particles, they collide more. Because there are more fraction of molecules which have energy greater than activation energy because they've increased the temperature. So there is now more, they are colliding more frequently with more energy. So it's basically it's a combination of both B and C. So answer should be D. So D explains best, right? So that is why D should be the answer, the only answer. Then we move on to question number 16. It says, what is the total number of structural isomers for cyclic alcohols with the molecular formula C4H8O? So they are asking for cyclic structures, cyclic alcohol with this formula. So one cyclic alcohol could be this, could be this one. There are 4 carbon atoms, so you give one OH. So this can be one structure. Another structure can be you can draw a triangle in the cyclic structure. So there can be a CH3 here, and there can be an OH here. So there are 4 carbon atoms, 1, 2, 3, 4, right? Another structure can be, you have 3 carbon atoms here, you have 1 carbon here, and 1 OH here, right? So this can be another structure. One more structure can be, let me think of another structure. So you place a triangle. If we place C4H8O, right, the number of structure isomers of cyclic alcohol. Yeah, so you place a CH3 here. You also place an OH here. So that's the 4th isomer. So there are 4 isomers. So there cannot be more than 4 isomers here. Not possible. Alright? So the answer is 4. We move to question number 17. It says, which is the correct equation for the incomplete combustion of butanol? Incomplete combustion would produce carbon monoxide and water, or it may produce carbon. So A and B can never be the answer because it produces carbon dioxide. So A and B, will be ruled out. So because they're forming carbon dioxide, incomplete combustion may form carbon monoxide as well as unburned carbon or carbon soot. Now in case of option C and D, now D is balanced wrongly. Because if you see here, the number of oxygen atoms on the left hand side is actually 10. So that's 4.5 into 2 is 9. That's 1 oxygen here. 1 plus 9 is 10 oxygen on the left. And you have 9 oxygen on the right hand side. So that's why option number D is wrong, because it is unbalanced. So C is the correct answer because it's a balanced equation and also it produces carbon monoxide. Then we move on to question number 19. It says, what amount in moles of oxygen is needed to convert 1 mole of pentane 135 triol into 3-oxopentanoic acid and water? How many moles of oxygen are needed? You're turning these into oxopentandioic acid, right? So you're supposed to react with O and produce this and water, right? So you have to balance hydrogen as well as oxygen, right? You have to balance both. Okay, let us count the number of hydrogen atoms on the left hand side and also the number of hydrogen atoms on the right hand side. So on the left hand side you have how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 hydrogen on the left. So on the right hand side, let us check how many hydrogen atoms do we have in this molecule in the product. So we have 1, 2, 3, 4, 5, 6 hydrogen only. We have 6 hydrogen atoms here only 6 hydrogen, right? So here we have 12 hydrogen, here we have 6 hydrogen. So we need another 3 hydrogen here, 3 water here. So that makes 12, right? 6 and 6 is 12 hydrogen. There's 12 hydrogen here, right? So let us now count the number of oxygen. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 oxygen on the right. And we have only 3 oxygen on the left. So the number of oxygen required will be 5. So the answer must be 5. So first we counted the number of hydrogen on the left of the organic reactant. Then we counted the number of hydrogen atoms on the right. Okay. So it was 12 and it was 6. So the rest hydrogen atoms will be found in water. From there we got the total number of oxygen atom, which was found to be 8 on the right. And in the organic reactant there were only 3 oxygen atoms. So from 3 to 8 you need 5 oxygen atoms. So that is why the answer is 5. So we move on to question number 20. It says, which compound gives the spectrum? So if you look here, A won't be the answer. A won't be the answer because A has a molar mass of 60. If you find its molar mass, the molar mass of A is found to be 60. So there is no prominent signal at m is equal to 60, right? So A cannot be the answer. So we rule out A. Now if you look at option number D, option number D has CH3CH2. Now CH3CH2 is equivalent to 29, right? The CH3CH2 has a mass of 29. So at 29 there is no signal. So we also rule out D. If you look at option C also has CH3CH2, which is 29. So we don't find anything here at 29. This is 29, right? That's 29, right? So there is no signal at 29. So we also rule out C. So B must be the answer because we have already ruled out all the other options. Okay. Then we move on to section B. In section B, we move on to question number C1. It says 2 observations that could be made. One observation that we can make, because when you are heating calcium nitrate here, the calcium nitrate decomposes into nitrogen dioxide and oxygen gas. So nitrogen dioxide is a brown colored gas, so you will see brown colored gas moving into the tube containing water that contains universal indicator. Another option would be that since nitrogen dioxide gas is passed through universal indicator, nitrogen dioxide gas is an acidic gas. So universal indicator shows red color in acid. So the universal indicator may turn red. You can write that the universal indicator turns red. So these are the 2 things that you can write. So in the marking scheme there was another answer that the solid also melts. Because you are heating strongly, this solid can actually melt. During decomposition, this solid can actually melt. Yeah. So I have already written the answer for you. Just let me show you the answer. You can write any 2. There are 3 answers here. So basically there are 3 answers here. You can basically write any 2. Just let me make it a bit larger for you. So there are 3 answers here. You can write any one of the two answers here. That a brown gas is formed, or you can write that the indicator turns red or the solid melts. Then we move on to question number D. Question number D says samples of calcium and magnesium are added to separate test tubes of cold water containing a few drops of universal indicator. Okay. State and explain the difference in the observation made in each experiment. Now when you add calcium to water, and magnesium to water separately, when calcium reacts with water, there will be effervescence. Because calcium reacts with water will form calcium hydroxide and hydrogen gas. Now when you give magnesium to water, it may give very few effervescence or may not give effervescence. Because magnesium is less reactive compared to magnesium. So since magnesium is less reactive, there will be very slight effervescence. Maybe you may not be able to see the effervescence as well. You may not see the effervescence. And with calcium reacting with water, it will produce calcium hydroxide, and calcium hydroxide is more soluble in water, and that is why the solution will be more alkaline compared to the magnesium hydroxide, because magnesium hydroxide has a very small solubility in water. So when calcium hydroxide forms, the solution is more alkaline compared to the solution of magnesium hydroxide that was formed, because magnesium hydroxide has a very small solubility in water. So calcium hydroxide will turn the universal indicator blue, because universal indicator in aqueous solution, in alkaline solution, the universal indicator usually turns blue. So the magnesium hydroxide solution will make the universal indicator less blue. So you can write that's another difference. And you can also write the equation of calcium reacting with cold water. So the answer, I have got the answer from the marking scheme. Let us look at the answer from the marking scheme. So these are the points that are to be included in your answer. You should write the equation. Calcium reacting with water produces calcium hydroxide and hydrogen. So there will be effervescence and it will turn blue. Now the reaction will be faster. There will be faster effervescence or more vigorous reaction with calcium, right? Because magnesium is less reactive than calcium. And you have to give the reason why this happens, because calcium has a lower ionization energy, or you can write calcium has more shielding, or calcium has more shells, or calcium has a larger atomic radius, and that is why calcium is more reactive. Now with calcium, the solution will be darker blue, because the solution is more alkaline, because the calcium hydroxide is more soluble than magnesium hydroxide. So all these should be included in your answers. And since this is a star mark question, your answer needs to be structured. Okay. Then we move on to question number 22. It says, why del RH1 can also be described as an enthalpy change of formation? Because this reaction produces 1 mole of magnesium oxide, which is produced from its elements in the standard state. So whenever 1 mole of a substance is formed from its elements in the standard state, is known as enthalpy change of formation, right? Because this reaction produces 1 mole of magnesium oxide, and which is formed from its elements, and the elements are in the standard state. So I have already written the answer for you. So you would write this, you have to include this in the answer, that 1 mole of magnesium oxide is formed, right? So for this you get 1 mark. 1 mole of magnesium oxide is formed. For the second mark, you have to write from its elements in the standard state, and that is why you can call it enthalpy change of formation, because this is actually the definition for the enthalpy change of formation. Then we move on to question number 23A3. It says skeletal formula of the only branched chain C4H9Br of C4H9Br primary bromoalkane. So let me draw the skeletal formula first. Let me draw the structural formula first, so it becomes easier for you to understand. So that's CH3, and we give another CH3. This is a branch. So there's H. Give a CH2, and you give a bromine. Now this becomes 1 degree, because the carbon bearing bromine has 2 hydrogen atoms. Now the carbon that bears the bromine has 2 hydrogen atoms, so it's 1 degree. This is also branched, and this also matches the molecular formula, right? Now, if you write this as the answer, you don't get marks because this is not the skeletal formula. This is a structural formula, or this is structural and discrete formula mixed together. So if you draw this, it would be given wrong because you're asked to draw the skeletal formula. And the skeletal formula would look like this. There are 3 carbon atoms in the longest chain. There's a bromine. There's a bromine here on carbon number 1, and there's a CH3 on carbon number 2. All right. Then we move on to question number. Next question was the next question. Question number 24A. 24A, it says you have to calculate the mean bond enthalpy for a single SF bond. You have to find the bond enthalpy of an SF bond. SF bond is found in SF6, right? So you have to use this equation and the value of del H to find the bond enthalpy of the SF bond. For this, we'll use the formula del H equals E in minus E out is the equation for the when we are using bond enthalpies or mean bond enthalpies. We use this equation del H equals to E in minus E out. So in case of E in, when bonds are broken, so in S8 there are 1, 2, 3, 4, 5, 6, 7, 8 bonds are broken. So in E in, you have to write 8 multiplied by bond enthalpy of the SS, because 8 moles of bonds are broken here in S8, right? Then bonds are also broken down in fluorine. In a fluorine molecule, there is 1 FF bond. Now, if you have 24 fluorine molecules, so 24 fluorine, it means 24 fluorine bonds will be broken. So this will be 24 times. So this would be 24 times the bond enthalpy of the FF bond, which is 24 multiplied by 151. So that would be E in, right? So let me show you E in here. If you want to calculate E in would look like this. Let me show you the answer. E in would look like this. So E in will be equals to the bond enthalpy of the SS and the bond enthalpies of the FF bond. So there are 8 moles of SS bonds, so you multiply by 8. There are 24 FF bonds, so you multiply by 24. So the E in will be equals to plus 5768 kilojoules per mole. Then we have E out. E out is the energy released when new bonds are formed. So in SF6, now the SF6 molecule, has 6 SF bonds, right? It has 6 multiplied by, it has 6 SF bonds. Now there are 8 SF6 molecules, so you have to multiply by 8 as well, right? So let me show you. So there are 6 SF bonds, so you have to multiply by, I think I've wrote this wrong here. Let me correct it. This will be E out will be equals to, there are 8 SF bonds in one molecule. Now we have what we have here. We have 8 moles of SF6 bonds. So this would be multiplied by 6 multiplied by 8. This number of bonds are present in SF. All right. Okay. Then we use the formula del H equals to E minus E out. Use the formula E in minus E out. Let me show you the answer. So del H will be equals to E in minus E out. A small mistake here. This would be, sorry, my bad. So this would be 8 into 6 multiplied by bond enthalpy of SF. And if you calculate, The answer is found to be 3 to 1.67 kilojoules per mole. So it is a very common mistake, which I also made. That I saw 8 here, so I forgot. I just wrote 8 here. So it will be 8 multiplied by 6 because one SF6 molecule has 6 SF bonds in it, right? All right. Then we move on to the next question. It says, give 2 reasons why your answer to A1 is unlikely to be represent the true SF bond enthalpy in SF6. One reason is that the bond enthalpy values are only for gaseous substances. But in this reaction, S8 was a solid. And secondly, the bond enthalpy values of SS and SF that we used were mean bond enthalpies. And mean bond enthalpies are actually average values which are found using several SF values in several different compounds. So it's not the actual value. So that is why it is unlikely to be accurate. So these are the 2 reasons I've already written for you. The one answer is that bond enthalpy data is based on gaseous substances only, whereas S8 is a solid. Bond enthalpy is an average for many different compounds. So these are the 2 reasons why the SF bond enthalpy that we found is not very accurate, or is unlikely to be accurate. Next question is about the bleach formula of the chlorine containing species at the highest concentration. At highest concentration is household bleach at pH 12. So at pH 12 is alkaline, right? If the pH 12 is alkaline, when it is an alkaline solution, pH 12 is alkaline, right? In alkaline solution, the concentration of H plus would be less. So this equilibrium will shift from left to the right. Okay? This equilibrium will shift from left to the right. And since it is alkaline, concentration of H plus would be less. So this equilibrium will shift to the left. So the concentration of this would be greater, so this would shift to the right. So the at greatest concentration, ClO minus would be there. Because at pH 12, this equilibrium will shift to the right because the concentration of H plus would be less. Since concentration of H plus would be less, this equilibrium will shift to the left. So the concentration of this would increase. If the concentration of this increases, this will shift to the right. So the concentration of ClO minus will increase, will always increase, right? And this would have the greatest concentration. So the answer to this question would be ClO minus. Then it says, explain why mixing strong acid with bleach is dangerous. Justify your answer using the equilibria shown. You have to justify the answer using all these equilibria. So you are mixing strong acid. If you mix strong acid, what will happen? The concentration of H plus would increase, right? If the concentration of H plus increases, the equilibrium 1 will shift to the left. If the concentration of equilibrium 1 shifts to the left, the concentration of HClO increases. Now, if the concentration of HClO increases, since this is also HClO, the position of the second equilibrium will shift to the right. When the position of the second equilibrium shifts to the right, the concentration of Cl2 will increase. Now when the concentration of Cl2 increases, right, Cl2 aqueous increases. When the concentration of Cl2 aqueous increases, the equilibrium 3 will shift to the right, producing more and more chlorine gas. Now chlorine gas is toxic. This is how we write the answer here. So I have already written the answer for you. This is how you should write this answer. So it's a good question, very good question. So this is how you should write the answer. This is a very good answer. It says the position of equilibrium 1 will shift to the left. So the concentration of HClO increases. It will shift to the left. So the concentration of this increases. And for this reason, the position of the second equilibrium will shift to the right. This will shift to the right. So the concentration of Cl2 will aqueous increases. So the concentration of Cl2 aqueous increases. As the concentration of Cl2 aqueous increases, the third equilibrium shifts to the right. Position of third equilibrium shifts to the right, producing more chlorine gas, which is toxic. Alright? Then we move on to question number 3. It says on heating, sodium NaClO decomposes disproportionates to form sodium chloride and sodium chloride 5. So you can write this equation very easily. I've already written the equation. You write the equation and you balance the equation. So if you balance the equation, your equation would look like this. NaClO decomposes into NaCl, disproportionates into NaCl and NaClO3. Quite a straightforward question because they've already told you what forms here: sodium chloride, NaCl, and forms sodium chloride 5. So you just balance the equation. Then we move on to question number... Oh, that's the end of this paper. Thank you.